Good afternoon, I am Mr. Ish. Thank you for watching. We're looking here at radical function attributes. Two questions, and we're learning here some of the fundamentals of precalculus. Discuss the attributes of the function root x. Graph of root x, very simply, is this. Let's start. We know for sure it's a function because it easily passes the vertical line test, VLT. It'll pass it. A vertical line will always cross this at only one point. It has a vertex where it kind of has this little starting point here at the origin, 0, 0. Additionally, it is a continuous function. Once it starts, it's continuous all the way through. It is increasing function only. In terms of its output, the range, the y values always get larger from its start point. As you increase the domain, the y values will only increase upwards. So therefore, it's only an increasing function. There's no decrease in it. What about the very important domain? How about from right here, 0, including 0 up to infinity? And the very interesting point about this with regards to range, it's exactly the same. 0, including 0 up to infinity. It definitely does pass the horizontal line test. HLT, any horizontal line drawn will only cross at one point. Therefore, for this function, you can very easily convert it into its inverse. And that procedure can be done. Once you get more comfortable with these inverse functions, you can address that more and get more into that. But right now, we're attributing this function as having an inverse over its domain, 0, including 0, up to infinity. So these are the attributes of this specific function you should know. And remember, with regards to continuity, there's no break in it. Once you start it, you can easily trace it without ever having to lift your pen or your finger. Let's look at the second question. If f of x were equal to 4 plus radical x plus 3 is within that radical, we have to find the vertex, domain, and range. You can always convert this into this form. You have right here x minus h plus k, and you can write it as that. We're looking really at x plus 3 plus 4. Here's my h value, here's my k value, but if you're looking at x minus h, what you're really looking at is x minus 3, which is how it got converted into a positive. You know, this here is your h, this here is your k. So the vertex very easily here is minus 3, 4. If you were to very well graph it, you're looking at this. 1, 2, 3, 4, and you know, like this. It would be a curve which would extend in this direction, just like it would if it were starting from the origin. So you know, just by looking at here, right here, the domain would be from minus 3, including minus 3, but going up to infinity. If you put minus 3 or here, you can zero out this and you can do a square root of a 0, and that's fine. But if you put any number less than minus 3, you'll have a negative in this square root, and you couldn't do that. Anyhow, right there is your answer. The range, you're looking here again from this new point vertex, and you're focusing here on the y value, and then you're looking upward. You'll go from 4 up to infinity, including 4, and that. A good clue over here with regards to domain and range is look at your vertex h value for your domain and look at your vertex k value or your y value here for the range determination, and then go from there. And this question has been completed. Remember, all of this vertex, domain, range, functions, all of that is huge in precalculus, and you need to know that. This function is continuous and it's increasing, and it has all the attributes that I mentioned earlier. Thank you for watching. Stay tuned. Bye.